Okay, folks, we're back. We got it all together. I did it off camera because it took a while to get everything lined up. And when we get it together, the bearings go into a little cup in each one of these, and that was what was the hard part to get lined up. But then I couldn't get it to squeeze together, so I got 3 pairs of vice grips and put one on this side down here, one on this side down here, and the other one at the top, and just started adjusting them, just squeezing them in until I got it all together. So she's doing real good. We put it in the vise over there and spun it by hand, and out of the white wire and the yellow wire I was getting 19 volts. I didn't check the pink and red wire because they are on the inner coil, so they would be less, but still they do produce. So we're getting 19 volts out of the outer coil only, and with the inner coil we ought to be able to get something. Now I put it over on 400 milliamps. I couldn't get that sucker to read anything. I mean, it dead stopped. It was reading 1/100th of a milliamp, decimal point 0.01 on the 400 milliamp scale, but I couldn't get it to go above that. So anyway, it was a good project. The next one I'll do with these little quarter-inch by half-inch neodymiums right there. Hope y'all can see that. They pull 11 pounds a piece, so that's quite a bit more than the ceramics. And they're half-inch. I don't know if they're going to fit inside and the stator still turn properly. If they don't, the thickness of the casing will allow for it. So what I'll do is I'll just drill 14 quarter-inch holes on this side, and then 14 quarter-inch holes on this side, and let the magnets come through till they just barely stick out on this side, and put the liquid nail on the outside. Since how they only pull 11 pounds a piece, so liquid nail should hold them, and that'll give me some clearance in there too. So you're talking 28 of those magnets, 2 for each coil. And by the way, I got a real good deal on them. I bought them over a year ago, and I bought 1,000, but I've given a few away. So now I have somewhere between 900 to 950. So I'm not scared to put them in there. And like I said, I got an exceptional deal on them. I got them for like 35-36 cents a piece. Right now they're going on eBay, that same size, in 42s, quarter-inch diameter, half-inch long. They're going for right around 60-65 cents a piece. People who sell these neodymium magnets are really proud of those things because they charge a fortune. In fact, I bought those bigger magnets I told you about, that there were 2 by 1 by 3/4. They were in 50s, I believe. And I forgot to check see exactly how much they did pull, but I do know it's way up there. It's like 105 pounds, something like that, a piece. And I still have the 1-inch by 1-inch by 4-inch long magnets that pull 205 pounds a piece. I'm going to use those in that big motor that when Scott was here a year or so ago, showed you on one of my videos, or our videos that we did together, about changing an induction motor to an alternator, permanent magnet alternator, where we drill the holes in the rotor and use fiberglass rosin to glue the magnets in. What I'm going to do, I've made a homemade lathe, very crude, and what we're going to do here real soon is I've got a 20-ton hydraulic press, and I'm going to take the rotor out of that motor and press the shaft out of the rotor. Then we're going to cut a rotor out of wood and put it on the lathe and turn it down. Then we're going to cut 1-inch wide, 1.25 inch deep slots in the rotor, and then we're going to take a piece of 1/4 inch steel or 1/8 inch steel, drill holes in it, and countersink the holes, and then glue them and screw them into the bottom of the grooves in that piece of wood rotor. And we're going to put 4 magnets in it and see what happens. It ought to do some real nice production with magnets that pull that hard and that large, cover that much copper. Like I said, they're 4 inches long. And the magnetic poles are on the 1 inch by 4 inch sides. So anyway, oh yeah, I started to say the 2 inch by 1 inch by 3/4 inch thick magnets that I bought, there were 48 of them, and it was like $480 some. No, yeah, $486, but that included shipping, handling, and everything. By the way, where I buy my magnets is on eBay from a place called CMS, and they're out of Plano, Texas. They're just about the best people to deal with for magnets, and just about the best price I have found so far. And I have bought a lot of magnets over the years, a lot. Oh, my wife gets on to me all the time, but what the heck? She knows it makes me happy, so she doesn't complain too hard. All right, kiddos, we'll catch you next time. And everybody have a great day. And I'm going to play with this one just for a little bit before I start on the next one. And like I say, I'm just learning how to do this, so I'm not getting real excited about using the big ones anytime too soon. The 1x2 by 3/8, because they do pull so much power. Like I say, they're a little over 100-pound pull each. And well, that just about does it. I'm going to play with this and see if I can't get somehow hook it up to one of my wind turbines and see if she'll do anything. If not, I'll give it to Scott and let him build a propeller for it. I can't use props in Louisville because they make too much noise, where my VAWTs make no noise at all. None. Not unless they get out of balance. But still, they're not legal because the law here in Louisville says you cannot generate usable electrical power by any means of wind power, which is absolutely ridiculous. But at the end of the ordinance or law, they do state, however, that under various conditions you can apply for a variance. And I've learned that several people in Louisville already have applied for a variance and got it. It depends on where they live, how close their neighbors are, blah, 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 how high they put their tower, the whole 9 yards. The thing I like about the VAWT is it doesn't have to be any higher than 6 or 8 foot, because the tallest person in the Dallas-Fort Worth Metroplex is 8 foot tall. So if you put it 8'6", then you can't walk into it at night, and your dogs and cats and other animals can't fly into it. Walk into it. So it definitely needs to have a fence around it, the VAWT, or at least 8'6" off the ground. Okay, I guess that's about it. As soon as I get the Savonius back together, balanced and back together again, then I'm going to make some videos of that, take it down and give it to the city council and apply for a variance. Okay, doke. I guess that just about does it for this one. Oh, by the way, I'm going to try my hand at winding my own coils and making my own alternator here real soon. So if you'll take a look at this, I bought a roll of wire a couple of weeks ago, and in that box, that roll of wire right there is 11 pounds, and it's schedule 38. 38 gauge. A lot of people say AWG gauge wire. Well, AWG stands for American Wire Gauge. So if you say it the way most people say it, then you're saying American Wire Gauge. Funny, I thought. Now, anyway, in the box underneath that coil is a roll of 34 gauge wire, and it's 23 pounds of wire. So I ought to be able to roll quite a few coils. Quite a few. Alright, thanks folks for watching. Appreciate it. Y'all have a great weekend. Oh, by the way, today is March the 9th. It's a Saturday. And it's, I don't have my watch, can't tell what time it is. Oh, here, I got my phone in my pocket, hold on. Okay, it's 1:09 p.m. in the afternoon. All right, talk to you folks later.